All right, so these first few are just a practice like your Quizlet. This is just like a lead in to the lesson. So what do you think about this one? Close. 5. 2 to the 5th power equals 32. How about this one? -1, it flips. This is why we do the Quizlet over and over again, is so when we get here, we know what's going on. All right, this one, -3. You need a negative because it has to flip, and then 3 cubed is 27. 3 squared is 9. All right, that was just, hey, let's practice some of our Quizlet problems, all right? So what we're going to do today are properties. Properties are not super fun because you kind of just need to memorize them, except they all make sense, okay? So I'm going to list these out and we'll make sure we all understand what's going on. All right, log base A of 1. I just put an A there. That's not a 9, it's an A, okay? A can be any number as long as it's not what? Base can't be what? Negative. You can't have a negative base. But that could be log base 2, log base 7, log base 10, whatever you want. What is that going to equal for any base that there is? 0. Because anything, I need for you guys to stop that and focus. Anything to the 0 power is 1. Now, I'm going to make another column for what it looks like with ln. ln of 1 equals 0. These mean the exact same thing, but it does throw people off when it's written as ln, so I always write it both ways. But do you get that these mean the exact same thing? Okay. This one's just e. e to the 0 equals 1. Okay, next one. Log base a of a. That would be log base 7 of 7 and log base 5 of 5. What do you think that's going to be? 1. A to the 1 equals a. The other way you can think of this is the log base a and the exponential base a canceling out. They undo each other. For the natural log version, it looks like that. ln of e equals 1. ln and e cancel out. They undo each other. They are inverses. All right. Next one. Log base a of a to the x power. That's exactly what we just talked about, except I put an x in there, so your answer is just x. You can think of it as like these canceling out. So over here, it would look like this. But again, those mean literally the exact same thing. I'm just writing it both. These are not two different pieces of information. I'm just writing it both ways because when it's written this way, it throws people off. But ln and e cancel. You just get x. All right. And then last one, if log base a of x equals log base a of y, then this is an if-then statement. Do you remember from geometry all those if-then statements? If it is raining, then I am sad. If it is not raining, then I am not sad. Yes, good. I was waiting to see if somebody would come up with it. Then x equals y. Like actually, yeah, because like I said, they all make common sense and you have common sense, so good job. But do you get that? If log base a of x equals log base a of y, then x equals y. All right, and for the ln version, if ln of x equals ln of y, then x equals y. Again, it's logical. It means the exact same thing. I just wrote it again. So now when we do our Quizlet, I have another version of it that includes ones like these. So these are going to get thrown into the mix. Okay. So when you look at this first one, do you see how there's a log base 4 and an exponential base 4? Yeah, they cancel and the answer is just 5. How about this one? 1. You've had ones like that in there already. ln and e cancel, so the answer would just be 4, but it's flipped, so it's actually -4. Now, I heard a bunch of you say the answer to this one already. That would be 0. Anytime you see a 1 there, it's going to be 0. It doesn't even matter what the base is. Any number to the 0 power is 1. And then what do you think about this last one? Well, the exponential base 12 and the log base 12 are inverses. They cancel, so it's just 40. This is whatever other number is there. All right. So we're going to take what we just learned and apply it to these. Do you see how we have log base 3 of this stuff equals log base 3 of 19? What do you think? Good. X squared plus 3 equals 19. As long as they're the same base, they can drop out. If this was a base 3 and that was a base 4, that wouldn't work. But I wouldn't give you something like that because that would be an undoable problem. Okay, and then you just keep going. Welcome back to our quadratic unit. What would you do to both sides there? Yeah, minus 3. And then square root. Now, when you do a square root, plus and minus. So plus and minus 4. Now, sometimes you have to get rid of certain answers because you can't log a negative. We get to keep the -1 in this case, though, because look, if you take -4 and plug it back in here, if you take -4 and square it, it's positive 16, so we're okay, but it's still good to think about it. Now, these don't have a base written. What does that mean the base is? 10. But the point is the same, okay? So we're going to take 2x minus 11 equals 5x plus 1 and then solve that. That's like welcome back to Algebra 1 class, okay? What would you do to both sides? Yeah, do you want to minus the 2x over? It's kind of up to you. If you wanted to minus the 5, that's fine as well. Are you guys purists? Do you like to keep the x values positive? Minus 1. Good. Now we check it. You can keep a negative answer as long as when you plug it back in, you don't have a negative inside the logarithm. I think this one's a problem, though. If you plug back in -4, that would be -8 minus 11, which is negative. So we have to get rid of that. And so it is no solution. So you can't log a negative number. Again, you can have a negative answer as long as when you plug it back in, it doesn't make the logarithm negative. So you just have to check. All right, these both have a base of what? E. The point is they're the same though, so you can set these equal. And again, this is welcome back to our quadratic unit. What would you do to both sides? Yeah, what do I call that? Evacuate, minus the 10. And you do that so that you can then factor it. No, it's not even a hard factoring problem. 10 would split. Yep, good, perfect. See, there's like, we don't like this, but then you all know the answer. All right, so you get 5 and you get -2. 5, I'm sure, is going to be fine. That's positive. But let's check the -2. No, we might be able to keep it, but let's just check. Oh, whoops. If you plug in -2, -2 squared is +4, and then -2 times -3 is +6. So did we get a negative in there? No, so we're good. We can keep it. Again, you can keep a negative answer as long as when you plug it back in, it doesn't make the logarithm negative. Okay. And then we have a few formulas as well. First one, log base A of u times v. And normally you won't see a little dot there. You'll just see whatever the two things are like next to each other. That equals log base A of u plus log base A of v. For the sake of time, I'm not going to write out, bless you, I'm not going to write out the proof, but this is the reason why. We're doing exponent rules in Algebra 1 right now. So this is an Algebra 1 thing. When you multiply, you add your exponents. That's why when this is multiplying, you are adding. For example, can you give me some single-digit numbers and I'll just make something up? X squared, 2 and 3 messes everybody up. Make it a number quick. Let's do 5. If you do x squared times x to the 5th, that is x to the, do you see what we did there? Same thing. All right. Now for the next one, it's going to be dividing. So if you have log base A of u divided by v, what do you think? When you divide, you do what to your exponents? Subtract. Multiplying means you add, dividing means you subtract. When we get to AP Calc, this right here is the thing. Everyone's like, we didn't learn this. I'm like, I promise you did. All right, third one. Log base A of u to the n power. This is the one that you do see sometimes. You are allowed to take the power and bring it out front as a coefficient. So you can write this as n times log base A of u. The reason that that works is when you do a power to another power, you multiply them. I'm going to use the same numbers that we just had. So if you have x squared to the 7th, that would be x to the 14th. Do you see that? So when you have a power to another power, like another exponent, you can multiply them together. If you feel like it'll help you to put the little dot in there, you can, but you're allowed to take the power and bring it down. It's multiplying. All right, and then the last one is called a change of base formula. So log base A of u, just remembering what letters of the alphabet I used for this. Say it was log base 3, but you wanted it to be log base 4, like you wanted to change the base. So you would be log base B, you're changing it to something else, of u divided by log base B of A. You just put this one over that one and you can change it to a different base. The reason we used to need that one is before the days of Desmos, the calculators would only do base 10 and base E. So if you wanted to type in log, here, actually I have some on the back. Here, I'll show you. Go to these ones and I'll show you what we had to do. So it would only do base 10 or base E. You couldn't type log base 5 of 37 in. Now Desmos will just do this. You can type log base 5 of 37. In the days before that, you had to change it. For base E, it would be ln. So you would just type ln 37 over ln 5. That's how we had to type them because it wouldn't work the other way. Do you get what I'm saying? And I'm not that old. This wasn't that long ago. Okay. Now, if you change it to base 10, you don't write the 10, it's just log. How, in the days of yore, how would you have to type this in? Now you can just type it the way it is, but we would have to type log 41 divided by log 3. That's how we had to type it. Because the calculator wouldn't do this. Do you get what I'm saying? It's kind of antiquated at this point, but that's how that worked. Okay. So what we're going to practice is expanding into condensing. It's basically just getting all the puzzle pieces into the right spot. The only note that I'm going to make is your numerator is going to be positive. When you multiply, you add is the reason why. Your denominator is going to be negative. When you divide, you subtract. So if you have a fraction bar in there, you've subtraction, it ends up being negative. But numerator positive, denominator negative is the, too long didn't read version of that is how it works, okay? So basically just trying to put all the puzzle pieces in the right spot. For this one, if it would help you to put a dot in between the 5 and the y cubed, you can do that. It's multiplication, which means we're going to add. So it is log base 2 of 5 plus log base 2 of y cubed. I'm going to just stop a second and let that marinate. Do you see what I did? I want to clarify, though, this is really important. You need to listen to me. I did not distribute a logarithm. That is not a thing. I used a property. When you multiply, you add. I need to be really clear about this. If you distribute a logarithm, you know how there's like right and then sort of right and almost right and like half right? That is so wrong. There is no partial credit I can work with you on. If you distribute a logarithm, that is like, you cannot do that, okay? Now, last step we're going to do here is, do you see this power, this 3? I'm going to take that and write it out front. So your final answer, log base 2 of 5 plus 3 log base 2 of y. That's your final answer. So it's just like puzzle pieces. You're getting it all right. Once people get good at these, they end up liking them because you're not really doing much math. You're just sort of rearranging the symbols. All right. If it helps you to put a dot in between the x and the e to the x, you can do that. This is multiplication. That means we're going to add. Does anyone want to give it a shot? Well, ln x, good, plus ln e to the x. Okay. Now, that first one we can't do anything with because it's just ln x. What do you think about this? We just went over it on the other side of the paper. Yeah, these cancel, and it's literally just x. All right, if it helps you to put a dot in between these, you can do that. Multiplication means we're going to add. So it's going to be ln. Oh, It would be ln x squared. I want to see if I can get you guys to skip that step. That 2, I can write it where? Yeah, in front. So 2, good at these. 2 ln x plus, now do you see how the second part has a square root? What power is a square root? Not 2. 1/2. So it is 1/2 ln of that stuff. Again, you can take the power and write it out front. The power for a square root is 1/2. What's your power for a cube root? 1/3. A fourth root would be 1. Okay, good. You're coming with me on that. This one's going to have 3 separate logarithms. We're going to have one for the x, one for the x plus 2, and then one for the x plus 3 squared. Oh yeah, that's the answer. We can't do anything else to that. Sorry. Expand. So instead of a single logarithm, you should have multiple logarithms being added or subtracted together. So this one is going to be log x plus, what else is in the numerator? Yep, log x plus 2 minus, again, dividing means you subtract. Anyone want to give it a shot? What's going to be in the denominator? 2, good, log x plus 3. That's it. How many logs are we going to have for this one? 3. You want to have 3 separate logarithms. Anything in the numerator is positive, denominator is negative. So you're going to have 2 things that get subtracted in this one. What do you think for the numerator? 1/2 log base 3 of x. Good, you guys are getting it. Minus, how about this second one? We're looking at this part right here. 3 log base 3 x minus 4. And then good, it's still minus because we're still dividing. Dividing means you subtract. And then the third one would be 3 log base 3 x plus 2. And that's the answer. Again, your goal is to write it as separate logarithms. The directions say expand. Now, what do the directions for the next one say? Condense. So that means you should only write log or ln. Perfect. Once. So you guys are good. So we're going to do exactly what we just did backwards. All right. So I am going to write log base 3 one time. And here's what I always suggest for everybody to do. I put parentheses and I draw a fraction bar. Anything positive goes where? On the top. Anything negative? Good. Perfect. You guys have got it. So for this one, x to the 4th goes on the top. And then do you see how it's minus? X to the 7th goes on the bottom. The most common mistake people make is they will put a negative in the answer. The negative just indicates it goes in the denominator. That's it. Okay, let's try this one. I'm going to write ln one time. And actually, I don't need a fraction bar in this one. Why not? I'm not even going to bother writing a fraction. It's all positive. There's nothing that's negative, so you don't need that. Now, do you remember how up here we took the powers and we wrote them out front? Now this 4 gets put back and it's an exponent. So good, it's going to be 2x to the 4th times, and you don't have to even put a dot. You can just put nothing, all right, times 3x. Good, you guys are getting it. Nice job. Bless you. All right, so we're going to write log one time, and I do need a fraction bar here because I see some negatives and I see a negative in there. Positive goes on the top, negative goes on the bottom. So for this first one, you take the 3 and you put it back. X squared to the 3rd. Good, thank you. X to the 6th. 2 times 3 is 6 is all that we did there. Now you don't put a negative in your answer. It's just indicating this should go on the bottom, all right? And we're going to take that 2 and put it back. X to the 10th, good job. Nice. This one's going to go in the numerator. If you want to put a little dot, you can, or just nothing. You're going to take the 1/3 and put it back. You don't want to write x to the 1/3 though. Good. It means cube root. If it was a 1/2, it would be a square root. I like these. They're like little puzzles. And we're not actually doing anything. We're just rearranging the symbols. They're just like little puzzles. All right, you're going to write log base 4 one time. Do I need a fraction bar? Yes, because I see a subtraction there. So what's going to go in the numerator? Okay, now hold on. I'm going to erase that. I'll fix it. You're not wrong about the x to the 6, but you also have to square the 5. So it would end up being what? Yeah, 25x to the 6. Good job. And it's because the 5 was in there too, like in the parentheses as well. And then down here, you're going to take the 1/2 and put it back, but that means square root of all that stuff.